Welcome to ATO's Another Expert Guide on BLDC Motor Control. Today, we'll walk you through how to build a BLDC motor control circuit, enabling precise speed and direction control using RS485 and CAN communication. Let's get started. To build this setup, you'll need the following key components. Make sure all components are rated for compatibility. If you're unsure, feel free to visit our website and consult our technical experts for specification details. Let's wire the circuit step by step. Please wire the components as follows. Begin by connecting the 24-volt DC power supply to the controller. Make sure polarity is correct. Next, wire the BLDC motor to the controller, ensuring proper connection of the three-phase wires. If your motor has a Hall sensor, connect it to the Hall input terminals on the controller. In terms of the communication setup, connect the RS485 converter and CAN analyzer to the controller's designated communication ports. All wiring must be properly connected as per the wiring diagram. Before proceeding, disable the RV terminal on the controller since we're using RS485 for speed control. We don't need manual potentiometer control. And set SW1 and SW2 dip switches to off. This prepares the controller for software control, not manual adjustments. For CAN communication, wire its CAN H and CAN L to the controller's CAN ports. While for RS485 communication, wire its A and B lines to the controller's RS485 ports. Power up the system and plug both devices to your PC via USB. Launch the BLDC control software. In the software, go to COM setting. Click Connect to establish COM connection. Upon successful connection, it begins reading parameters. Once the reading is complete, this signifies the BLDC motor controller is successfully connected. If connection fails, determine the controller address and baud rate, and verify your COM port in Device Manager under Ports, COM and LPT. Go to Parameter Setting and set PN14 and PN15 to 3. This configures CAN bus as both data and control input. Open the CAN software tool and click Continue. From the Select Device dropdown, choose your device. Keep default baud rate at 500 kbps and click OK and start CAN. Upon successful connection, the system will automatically begin receiving heartbeat signals. Click Pause to stop data stream scrolling. This is the real-time feedback of the motor status with 00 as the CAN ID. Use extended frame format and ensure the frame ID matches the controller's communication ID. To send a 3000 RPM counterclockwise rotation command, the binary target data should be set as follows. The target data is 0x8BB8. Bit 0-13 is responsible for target speed control, and bit 14 to 15 controls motor direction. For proper command transmission, byte 6 must differ from the previous command. And bytes 7 and 8 must equal the checksum of byte 1 to 6 to prevent transmission errors. Set send interval to 1000 milliseconds. Click Continue and Send to transmit the frame. Here we click Pause to stop receiving data temporarily. Here, as you can see, this is the command that's just being sent. And the controller sends back real-time status data, including the following messages. To stop the motor, send a stop command with the target data set to 0x00. Ensure that byte 6 must differ from the previous command. Click Continue and Send to execute the command. And you can see the motor stop running. Click Pause to stop data transmission. Let's issue a new command for 500 RPM forward rotation. Always recalculate and update the checksum before sending. Click Continue, then Send to issue the command. The system should now respond with state feedback. And that's a complete overview of how to control a BLDC motor using RS485 and CAN communication. Whether you're building a prototype or integrating into an industrial environment, these steps ensure reliable, real-time control.